Let's dive into classes and objects in C#, fundamental concepts in object-oriented programming. A class is a blueprint for creating objects. It defines the properties and methods that objects created from the class will have. Here's a simple class definition in C#. We'll create a person class with properties for name and age. This person class has properties for name and age, and a method called greet. To create an object from a class, you use the new keyword. Here's how to instantiate a person object. Here, we create a person object, set its properties, and call the greet method. Classes can have methods that define action. In the person class, the greet method prints a greeting using the object's properties. Methods can perform operations on the class's data or interact with other objects. Constructors are special methods that initialize objects. Here's how to add a constructor to the person class. Now, you can initialize a person object with specific values when you create it. That's an overview of classes and objects in C#. Experiment with creating your own classes and using them in your projects. Let's explore constructors in C#, a key feature for initializing objects with custom values. A constructor is a special method in a class that is called when an object is instantiated. It initializes the object state. A default constructor is one that takes no parameter. It's provided automatically if no constructors are defined. In this example, the default constructor sets default values for name and age. A parameterized constructor allows you to initialize an object with specific values. This constructor initializes the name and age properties with values provided when the object is created. You can overload constructors to provide different ways to initialize an object. Here, person has 3 constructors: a default constructor, a parameterized one, and one that initializes only the name. Constructors are used to ensure that objects are created in a valid state. They help set up initial values and can enforce certain rules. That's an overview of constructors in C#. Experiment with different types of constructors to get comfortable with initializing objects. Let's dive into inheritance in C#, a key concept in object-oriented programming that allows you to extend and reuse code. Inheritance allows one class to inherit the properties and methods of another class. This promotes code reuse and establishes a hierarchy. Here's how to create a base class and a derived class. We'll start with a vehicle base class and a car derived class. The car class inherits from the vehicle class and adds its own properties and methods. A derived class can access public and protected members of the base class. Here's how to use the car class. The car class can use the start method from the vehicle class and its own honk method. You can also override methods in a derived class to provide specific implementations. Here's how to override a method. The car class overrides the start method to provide a custom message. You can use the base keyword to call the base class version of an overridden method. This allows you to extend the functionality of the base class method while preserving its original behavior. That's a quick overview of inheritance in C#. Practice using inheritance to create more modular and reusable code. Let's explore polymorphism in C#, a powerful concept in object-oriented programming that allows for flexible and reusable code. Polymorphism means many shapes. In programming, it allows methods to do different things based on the object it is acting upon. Compile-time polymorphism, or method overloading, occurs when multiple methods have the same name but different parameters. Here, the add method is overloaded to handle both integers and doubles. Runtime polymorphism, or method overriding, allows a derived class to provide a specific implementation of a method already defined in its base class. In this example, the speak method is overridden in both dog and cat classes. Using polymorphism, you can write code that interacts with objects of different classes through a common interface. Here, myAnimal can refer to objects of different types, and the appropriate speak method is called based on the actual object type. That's an overview of polymorphism in C#. Use polymorphism to create flexible and extensible code structures in your applications. Let's dive into abstraction in C#, a concept that helps in managing complexity by focusing on essential features and hiding implementation details. Abstraction allows you to define the structure of a class without specifying the exact implementation. It helps in simplifying complex systems by hiding unnecessary details. An abstract class cannot be instantiated directly. It can contain abstract methods, which must be implemented by derived classes. Here, shape is an abstract class with an abstract method calculated calculate area, and a concrete method display shape. A derived class must implement all abstract methods from the base abstract class. In the circle class, we provide a specific implementation for the calculate area method. Here's how you can use an abstract class and its derived class. Even though shape is abstract and cannot be instantiated, circle can be instantiated and used. That's a quick overview of abstraction in C#. Use abstract classes and methods to simplify complex systems and focus on what's important. Let's explore interfaces in C#, a key feature for defining contracts and ensuring consistency across different classes. An interface in C# defines a contract that classes can implement. It specifies methods and properties that a class must provide without defining how these methods and properties are implemented. Here's how to create an interface and implement it in a class. In this example, iDrawable is an interface with a draw method, and Circle implements this interface. A class can implement multiple interfaces, allowing it to fulfill multiple contracts. Here, Document implements both iDrawable and iPrintable interfaces, providing implementations for both draw and print methods. Interfaces can also inherit from other interfaces, allowing for more complex hierarchies. In this example, IsShape inherits from iDrawable, and Rectangle implements IsShape, providing both draw and area properties. That's a quick overview of interfaces in C#. Use them to create flexible and consistent designs across your application. Let's dive into encapsulation in C#, a fundamental concept in object-oriented programming that helps protect data and enhance flexibility. Encapsulation is the concept of wrapping data and methods that operate on the data into a single unit, typically a class. It helps control access and maintain the integrity of the data. C# provides access modifiers to control the visibility of class members. Common modifiers include public, private, protected, and internal. In this example, name is a private field, and setName and getName are public methods that provide controlled access to it. By using encapsulation, you hide the internal state of an object and only expose what is necessary through public methods or properties. Here we use setName and getName methods to interact with the name field, ensuring that any validation or business logic is encapsulated within the person class. Properties provide a more concise way to encapsulate fields and control access. They combine get and set methods into a single unit. In this example, salary has custom logic to prevent negative values, providing a cleaner and more maintainable way to handle data access. That's a quick overview of encapsulation in C#. Use it to protect your data and design robust and maintainable systems.